Hello, everyone, and thank you for tuning in to the Max Planck Florida Machine Shop virtual tour. Thank you for joining us today. While we wait for everyone to tune in, we are going to start with a video about the Max Planck Florida High School Summer Internship. And as a reminder, you can send us your questions. Just ask to your teacher to type them to the chat, and we will do our best to answer them. So now have a look at our high school summer internship, and hopefully some of you will apply for next year. My name is Ilaria Drago, and I am the Head of Education Outreach here at the Max Planck Florida Institute for Neuroscience. The high school summer internship is an internship open to the rising juniors and seniors attending a Palm Beach County school, and it is an opportunity for high schoolers that are passionate about science to spend 6 weeks in one of the Max Planck labs or core facility and work side to side with Max Planck scientists on a real scientific project. This internship is the perfect opportunity for students that are excited about science and they want to move from the books to really get their hands on in real experiments, to experience the frustrations and the joy of seeing the result of your work and to understand something for the first time as a scientist and possibly having an impact on the future.
They all just really want to watch what you're doing. They also have the opportunity to build long-lasting relationships with their mentors, their peers, and other people they encounter here at the Institute.
When I was applying for this internship, I was hoping to get more knowledge in neuroscience because it involves a lot of my favorite subjects in school, such as biology, chemistry, and physics, as well as some practical experience and valuable connections. I've been able to learn about new technology and how to use it, including the confocal microscope. I've actually been able to patch a few cells yesterday, so that was really exciting for me.
I'm on a robotics team with many other previous Max Planck interns, and each one of them, after the internship, came back a better engineer and a better just designer. I've had the opportunity to use different CAD softwares. I've always been interested in pursuing engineering, but definitely more interested in now doing engineering as related to the human body and the human brain.
You're not going to find like a specialized neuroscience center like Max Planck anywhere near here. The fact that it's just like in our backyard and it was open for us was a really amazing opportunity for me. I've had the opportunity to do a lot of things. I've been playing around in VR, viewing a lot of different brain MRIs, cells, synapses. I've been able to watch a few mouse surgeries. I've been able to watch virus injections, immunostaining. I've been able to see basically anything I want to see. I've been able to find someone who's willing to show me.
This internship has gone on to solidify my love of neuroscience. We've gotten a lot of opportunities and experiences here at Max Planck. I've gotten to watch a lot of brain surgeries on mice, such as viral injection, and I've learned a lot about reading articles and doing scientific research, as well as using the light microscopy devices like the STED and ARI scan.
This experience gives me hope for the future. Sometimes there is this stereotype that high schoolers don't care much about the greater good of the world or they don't have big dreams. And I have to say that these students, year after year, they give me more hope for the future because they are not just smart and they are going to do amazing things in their life, but they are also kind, genuine, and humble humans. So this was a video about our high school summer internship, and actually today you're going to hear more from one of our high school interns. And as a reminder, please type your questions in the chat. And now, before really starting to talk about the machine shop, we would like to show you a video to let you understand more about the Max Planck Florida Institute for Neuroscience and what we study here.
The Max Planck Florida Institute for Neuroscience is a nonprofit research organization that studies the brain. Max Planck Florida is part of the Max Planck Society, a network of more than 86 scientific institutes throughout the world. MPFI is the only Max Planck Institute in North America. What makes a Max Planck Institute special is our emphasis on curiosity-driven discovery. We encourage our scientists to take bold, unconventional approaches to understanding how the world around us works. MPFI brings together scientists at all career levels, from high school students to seasoned research group leaders, who work together using state-of-the-art technology to help unravel the fundamental mysteries of the brain. Our institute is located on a shared campus with Florida Atlantic University and Scripps Research, allowing us to engage in exciting scientific partnerships. Understanding the brain remains the ultimate challenge for biology. Neural circuits, the complex synaptic networks of the brain, hold the key to our understanding of who we are, why we behave the way we do, and how the debilitating effects of neurological disorders can be stopped. Flexible spaces make it possible for scientists to build and customize the tools that they need to pursue a specific research focus. Because we approach research in ways that might not have been tried before, we often require specialized parts and equipment that can't be found for sale elsewhere. The Max Planck Florida Mechanical Workshop designs and builds commercially unavailable equipment and customizes existing tools for use by Max Planck Florida scientists. Our mechanical workshop is known internationally for its quality workmanship and ability to create solutions to challenging technical problems. Our expert machinists are often called on by leading research universities and top scientists who trust them to design exceptional parts and equipment for their projects. The mechanical workshop allows our scientists to bring bold ideas to life and helps make it possible to pursue new lines of questioning that will allow us to better understand the brain. Being located in sunny South Florida, there is plenty of beautiful scenery to enjoy. But while a view of palm trees may be impressive, Max Planck scientists are just as excited about another view that can only be seen through the lenses of powerful microscopes. High-resolution imaging technology is constantly changing, making it challenging for individual laboratories to keep up with new developments. But at MPFI, our scientists don't need to worry about that, thanks to the support and expertise of our talented imaging professionals in the light microscopy corps. Our light microscopy tools include conventional fluorescent microscopy, confocal microscopy, as well as two-photon microscopy, giving researchers the power to view structures typically 5 to 20 times deeper than other types of fluorescent microscopes. Our imaging center also features a super-resolution STED microscope developed from Nobel Prize-winning technology that can show fine structures that are invisible in traditional microscopy images. When a scientist can work closely with technical experts, great things result. Max Planck Florida is home to one of the nation's leading electron microscopy facilities. EM is a powerful type of microscopy that allows researchers to see parts of the brain with incredible detail, creating dynamic three-dimensional images of the structure of cells. The human eye can see an object as little as 100 micrometers, or about the thickness of a human hair. But these powerful microscopes can see objects 100,000 times smaller, down to the single protein of a cell. The MPFI EM core has several tools available, including scanning electron microscopes, a transmission electron microscope, and a freeze fracture replica system that allows minuscule proteins to be labeled with gold particles, making them easier to track. With all of their expertise and powerful technology, MPFI's EM core makes a significant contribution to Max Planck Florida's scientific discoveries. Max Planck Florida is more than just a place for scientists to do cutting-edge research. It's a community. It's through a spirit of collaboration that Max Planck Florida drives neuroscience forward, using creativity to tackle some of the most important questions in science today. We hope you'll be a part of our community. Max Planck Florida, where curiosity meets discovery. Visit mpfi.org to sign up for email updates or follow us on one of our social media channels at MPF Neuro.
Welcome back. So now we are really ready to start talking about the main topic of this virtual field trip, the Max Planck Florida Mechanical Workshop. And actually we are here in the mechanical workshop now talking to you. I want to introduce our special guest today, starting from our master machinist, Marcus Clement. Can you introduce yourself,
Yes.
Marcus?
Hello, my name is Marcus Clement. I'm the Master Mechanical Engineer at the Max Planck Florida Institute.
And our second guest today is Sam.
Hi, my name is Samuel Breslin. I attend Atlantic Community High School, and I'm a high school intern here at Max Planck.
So to start to break the ice, I want to ask to both of you a question. How did you first got interest into machining, and how did you end up here at the Max Planck Florida Institute? Marcus.
So in my case, I was always fascinated by airplanes. I started in Germany. I started an apprenticeship program to become an aviation engineer, and the company went bankrupt while I was there. But during that apprenticeship program, they taught me things about machining, and that fascinated me. So I was able to transition to a Max Planck Institute in Munich, Germany, to finish my apprenticeship program. And from years later, after the finish of that apprenticeship program, I was offered to come to Max Planck Florida Institute to start this machine shop.
How many years are you working here? I think you're one of the
12
first.
years.
12 years. You're one of the first employees,
Yes.
I remember. And Sam, how did you got into machining, and how did you end up here at Max Planck?
So I first started by joining a robotics team. I joined a robotics team in 8th grade down in Boca. And we used a lot of 3D printers, laser cutters, and every once in a while we would get to use the CNC machine at FAU. And so one of the older students on the team, his name was Billy Swan, and he was an intern here at Max Planck, and he recommended that I apply, and so I applied and I got the internship, and now I'm here.
Thank you so much. So we are going to show you a few videos, but before that, I want to remind you that you feel free to send your questions. Please remember to also include the schools you are typing from, and feel free to send questions for Marcus, for Sam, for both of them, or if you have any specific question about the videos that you are going to see. The first video that we are going to show you is a true virtual field trip of the machine shop. So someone is going to explain you each of the machines that we have here in the shop, and then we can answer all the questions that we didn't answer with the video. So this is the mechanical workshop video.
Here at the machine shop, we have a variety of machinery to help us make the parts for the scientists for their laboratories. And one of the main ones that we use the most is our 5-axis CNC milling machine. I'll open the door here so you can see inside. It has the traditional X, Y, and Z axes, but the other two axes really help make our life a lot easier and the parts more accurate for the scientists. So first we'll show the B axis, which rotates from 30 degrees to 120 degrees in both directions. And then the other axis is the C axis, which rotates a continuous 360 degrees. This allows us to reach all 5 sides of the part in addition to any compound angle within those 5 axes. So we can make very complicated parts very simply, relatively speaking. We cut a variety of metals, specifically aluminum, titanium, stainless are the primary ones we use, but we also do cut plastics as well on this machine. We use a rotary tool. This here is a drill, but we also have end mills that help remove the material, and we use a cutting fluid. There's a white cutting fluid, and that is just a coolant because when we're machining there's a lot of heat generated and a lot of friction generated, so that coolant helps keep the tool cool, the part cool, helps keep the material from sticking to the tool. So you might ask, well, how do we program these machines to run these parts? We use a software called SolidCAM, and this is a integrated software to use with SolidWorks. So we design the parts in SolidWorks, and then we can import that into SolidCAM, and we create a program. We load different tools into the program. We tell it when and where the part is, how fast to cut, how deep to cut, and we can also load fixtures. So this is a very complicated sample holder, and we can't hold it just in a traditional vise, so we needed to create an additional fixture. This is this you see here, and we can load that into the simulation so we know if we're crashing into anything. We don't want to crash into anything, just like you don't want to crash your car, we don't want to crash these machines. So here's a simulation. It is crashing into the screw heads there, but very minimal, so we're not going to worry about it. But just to illustrate that it will show you if it crashes. SolidCAM will generate the post. The post is basically the dialogue that the machine uses. It's the machine language. And this particular language is called Heidenhain. There's a variety of different languages depending on the machine manufacturer. That gets imported into the machine, and then the program gets installed onto the machine, and once we hit start, this is how the machine runs. So another machine that we use quite often is the EDM machine. EDM stands for electric discharge machine. It basically uses a metal wire that has a variety of current and voltage settings depending on the type of material, how thick the material is, and it uses this to create a spark around the wire. And this spark will kind of erode away at the material. It never actually contacts the material. The wire never touches the material. I always like to describe it as kind of an electrical bandsaw. The wire diameter is only 1/4 millimeter, 0.25 millimeters in diameter, which is about, maybe if you put 2 to 3 of your hairs together, it's about that thick. So very small, and with this small diameter, we're able to make very complex shapes super easy. And we're able to make things that would otherwise be almost impossible on a standard CNC milling machine. A full spool of wire holds 13 miles of wire. So it's a lot. It weighs about 18 pounds. And the material has to be conductive, so it has to be some sort of metal. We can't cut plastic or glass or ceramic. It has to be conductive in order for that electrical current to be complete. I like to say there's nothing impossible that can be done, but it can get very, very complicated and not necessarily worthwhile. So this is another machine that we use quite often in the shop. This is called a lathe. It's a CNC lathe, and it is used to turn cylindrical parts. So the mill can cut any shape, but the lathe is specifically for cylindrical parts. So you would have a round piece of stock such as this, and you would clamp it in the chuck, and you would program it to cut this profile. An example of a part that we would make on this would be an objective adapter for their microscope. So a scientist has a microscope, they've been using this style of objective, they now want to use a different objective, but it doesn't screw into their microscope. So we make an adapter with the 2 mating threads where they can then use the new objective in their setup. This machine here is a manual milling machine. It does have a computer-aided control, so we can write simple programs. We mainly use this machine for large parts that won't fit in the CNC mill, or for kind of simple, quick parts, say a bracket to mount something to a desk or something like that. So parts that aren't very complicated, we can quickly knock them out on this machine. Same concept as the CNC milling machine. It uses a rotary tool. This here is an end mill. This is what we use to shape the parts. We can mill the top of the part around the profile of the part. We can cut pockets in the part, steps in the part. So most of the machines in the shop are very safe. The CNCs are completely enclosed. You can't run the machine with the door open, so they're not necessary to have safety glasses. But this machine is all open, chips are flying everywhere, so you always want to make sure you wear your safety glasses. So I'm just going to find the top of the part by gently kissing it. And then I'm going to zero my datum. You got it? And that is our manual milling machine. So this is our stock storage. We have a lot of drawers filled with a variety of material. This is kind of our big aluminum drawer. So depending on the size of the part, we are ready to grab any size material that will be big enough for the part. So that's aluminum. We also have stainless. That drawer gets a bit heavy. Titanium, brass, copper. We machine it all.
And this was the video about our mechanical workshop. So now I have a few questions for Marcus and Sam. So I'm going to start with you, Marcus. If you have to pick one machine, what's the machine you prefer to work with and why?
It's this machine behind me. It's called a 5-axis CNC milling machine. And the reason why I like it so much is it allows me to create pretty much any shape that you can imagine by using this machine, cutting material into that shape.
Does this machine have any drawback?
Very few.
Can you cut any material or?
Pretty much any material,
Yes.
other than stone, maybe glass would be a limit.
And Sam, what's the machine you prefer to work with?
So I would say my favorite machine is probably a laser cutter inside. I don't think you saw it on the video, just because it's an extremely quick machine. So while it is pretty limited on what it can do, you can go from your CAD designs to a physical object extremely fast. And I also love working with our manual mill inside here, which I believe you saw in the video. And while it isn't as automated as some of the CNC machines, it's definitely enjoy working with it. It seems like time flies by when you're using it.
Thank you so much. Another question for both of you. What is the hardest part of working in a machine shop, in your opinion or in your experience?
The hardest part working in this machine shop is definitely bringing out a good product that you don't have the necessary information for that you need, because a scientist will not give you the full details of the part that he wants. He just comes with an idea, and it's your responsibility to bring this idea to a functional part, piece, or assembly.
So if I understand correctly, what you're saying is that we are not a standard machine shop in which we do the same part many times, but basically every day you have a new part to produce, and you don't necessarily have all the details, but you have to figure them out as you go, and that is very challenging.
Yes, that's correct.
In your opinion, Sam, what's the
So,
hardest part?
For me, it was definitely sort of developing like an eye for detail. Coming from high school robotics, it was the parts that you made really only had to work once, and they didn't have to look very good. As long as they worked, it was fine. But here, they have to be extremely precise, and they have to look good. So that was definitely quite the experience. Developing the eye for detail that you need here.
Thank you so much. And if some of the students that are there watching this video are wondering, maybe this career is for me, what do you think is the number one skill that they should work on improving to be successful in a machine shop?
You have to be very, very detail oriented, so that you don't scratch parts, that you don't drop them accidentally and ding them and they're not usable anymore. You have to be clean, because if you're not working clean, then you create a hazard for yourself or others. So I would say these are definitely the most needed skills.
Sam, what do you think is the number one skill for some student, for example, that wants to apply to the high school summer internship? What skill do they have to do a good job here?
Well, I definitely agree with what Marcus said, an eye for detail. But also, if you look at I guess more tangible skills, like CAD design was the most important thing. Basically learning how to, take an idea in your head or that a scientist gave you and turn it into a model that you can actually machine or laser cut or 3D print.
Thank you so much. And so this was my water bottle. And so now the second video that we prepare for you is what we call a journey of a part. And it is a video about what we do here every day at Max Planck. What Marcus explained a little bit is that scientists have an idea and they come here, they talk to Marcus, and they ask him to do a part that does not exist. And Marcus is left with the task of figuring out. And so we created a video to tell you a story of one of the parts that the machine shop recently produced in collaboration with one of the Max Planck Florida laboratories. And so while you watch this video, please feel free to send all your questions for Marcus and Sam.
I'm Salil Bidaye.
My name is Marcus Clement.
My name is Samuel Breslin.
I'm a research group leader.
And I'm the master mechanical engineer.
And I work here at Max Planck in the mechanical workshop as a mechanical workshop helper.
The role of the mechanical workshop at MPFI is to help our scientists to solve problems that they face on a daily basis.
Whether they be small parts or larger projects.
General machining is you're taking material away from a product that is already there. You just shape it into a different shape. 3D printing builds layer by layer by layer, and you can watch every single layer.
Machine shop does a lot of custom hardware for everyone at the institute. We wanted to have a way to position the animals in a high-speed video recording setup where we can manipulate their neurons and at the same time record their leg movements at higher resolution. So we wanted a way to position the animals perfectly on a treadmill. This needed a custom solution, so we couldn't buy anything off the shelf because it had to perfectly fit So we came up with a rough sketch of a holder that would help achieve that.
The way he would like to hold the fly is using a manipulator. Salil and I met in his lab for me to see what the issue was and to take a couple of measurements. Then I took those measurements down and talked to Sam. Sam is a high school intern that works in the machine shop after school. He does a lot of machining for us, does a lot of CAD designs.
Fabricating things as well as electronics and programming. I love, constantly having new things to work on.
Marcus produced a series of prototypes for us, and we tested all of them.
Using a 3D printer to print him a physical prototype that he was able to use in an experiment. It turned out that certain things didn't work out as planned, so we needed to make some adjustments. I reprinted the initial version with the modified tip. He used that in his experiment, which turned out not to be as great, so I had to redesign the part.
And then we figured out the one that worked the best.
So essentially this part is used to hold the fruit fly onto a treadmill. So at the end of the part, a needle is placed over the end of the part and a fly is attached to the needle, and the larger end is attached into a micromanipulator. So basically it allows them to make very small adjustments to where the fly is. Once it's done printing, it would essentially be to process the part, remove it from the supports that it was printed with, sand down all of its sort of imperfections, and then polish the part. It sort of outlines the purpose of the machine shop here at Max Planck. We can make a large, intricate project or just a part to hold a piece at an odd angle. It shows like the precision, we can hold a fruit fly in a specific place.
Without this workshop here in the Institute, what we would have to do is essentially first produce a formal model, hire an external vendor to produce all these prototypes for us, which would take much more time and money. And more importantly, we would lose the expertise that Marcus provided, and as biologists, we would most likely not come up with the efficient design that Marcus came up with. This really impacts the pace of research in our lab and in fact makes it better.
The fun part about this job is that you get to meet with everybody who's involved, from the idea to the finished product. You machine one part, you see it in action, and then it's very satisfying if it works. The value here is that a scientist faces a problem and he can just go to someone and ask for help or input. In the mechanical workshop, we work together with a scientist to solve the problem.
So to start talking about this video, about the journey of a part, Sam, you did a lot of parts in the almost 1 year that you are working now at Max Planck. Was this part for the BDIE lab an easy one or a hard one?
This was definitely an easier part as far as the process of actually fabricating it. All you really had to do was 3D print it, and then once we finished printing it, we wash the part and then cure it, and then we basically post-process the part. So sand down all the bumps from the supports, and then polish the part. So as in the terms of the complexity, it's definitely not one of the more complex parts, because sometimes we'll do large assemblies of parts here, like what I'm currently working on. So yeah.
And for the people that are not really used to the terminology, what do you mean when you say that you have to cure a part?
So we'll put it in it's basically a machine. It heats up the part and almost dries it out a little bit. Well, the 3D printer that we use for this part is an SLA 3D printer. So it basically uses layers of resin and cures each resin layer. But sometimes the part is completely cured, so it has to be cured afterwards as a whole part in basically a toaster oven.
Thank you so much. And Marcus, this is a question that we get from a lot of the people that visit the machine shop. Did you ever think about patenting one of the parts that you created here in the machine shop?
No, we're not thinking about this, or we have never thought about it, because the idea is that we're sharing our findings with the society or with other research labs, that they can either duplicate what we are doing and find other other solutions to their problems, or that we're just making it available for anybody. Yes.
So you basically share freely the designs and everything after you found the solution for the problem of how to build this part.
Yes.
Perfect. So this is kind of connected. Do you build parts only for the Max Planck Florida Institute, or you also build parts for outside the institute?
So if we're not too busy for working for our institute, we offer available time slots to local universities or research facilities as Scripps or FAU, but we also have customers from all over the country and actually all over the world. We have sent parts to Japan, Singapore, to Europe, Australia. People hear about us just getting a tour from somehow, and then the word just spreads somehow.
Thank you so much. I just got an idea. We should have a map of the world, and we should put a pin on where all our parts went into the world.
That would actually be a good idea.
So another questions that we hear a lot is like, did it ever happen that you have to tell a scientist, I'm sorry, but I'm not able to machine the part you need?
This happens more often than you think. Sometimes it's just physically not impossible, or we don't have the right machines for it. We don't even have all the necessary details available. Like, it happens a few times that we can't fabricate something.
But usually you make it happen.
Yes.
And Sam, a question for you now that I think a lot of our viewers can identify you, because you're still in high school, but you're also working here in the machine shop. So can you tell us a little bit more about your experience coming from doing robotics competition to work here full-time at Max Planck last summer?
So the internship program was great. I definitely learned a lot, moving from sort of a place where I was a leader to a place where I can learn a ton. And I've also enjoyed some of the different applications of the parts I make, as opposed to high school robotics. Getting to make parts for something completely different, for neuroscience research. It's also been fantastic working with all the scientists. So. And learning about their experiments. All of them are extremely open about what they're working on and what they're looking to find. So it's been a fantastic experience.
Thank you so much. So I think we answer all the questions for today. But if you have more questions, feel free to email them at education@mpfi.org. We will do our best to answer them. Also, please follow us on social media. Our handle is MPF Neuro, and we have a lot of opportunities for high school, middle school students. So please check it, and we hope to see you soon here in person at the Max Planck Florida Institute for Neuroscience. Thank you for tuning in, and thank you to Marcus, to
pleasure.
Sam, to Kevin, that is the person that did all the videos and all the stuff at Max Planck that made this live stream possible. Thank you so much.